Hello and welcome to Engineers Mindset. So in order to back our analysis on inclined plane friction, let's consider the question on the board. But before getting to that question, if you missed the first two videos on friction, I'm going to leave the link in the description of this video. Do well to watch it for proper understanding. Alright, let's get straight to the question. So this question says, a 14 kg block is placed on a rough surface inclined at 30 degrees to the horizontal. If a force P acting along the plane is applied to the block in the upward direction, find 1. The value of P to cause impending motion along the plane. 2. The value of P to cause impending motion down the plane. Take the coefficient of kinetic friction as 0.4. Okay, so let's start by plotting our diagram first. All right. Okay, so this is a block and the mass of this block was given as 14 kg. So mass equals 14 kg, and this block is placed on an inclined plane, inclined at 30 degrees to the horizontal. So the angle here is simply 30 degrees. Now, we were told that a force P acting along the plane is applied to the block in the upward direction. So which means this force is applied to this block in the upward direction, causing the block to exhibit motion up the plane. And in all our series so far on friction, I've said whenever a force is applied, then the frictional force is always to oppose the motion of that force. So if this force P is pushing this block up the plane, it means that I have a frictional force which is acting where? Down the plane. And mind you, from the question, we were given coefficient of kinetic friction to be 0.4, which means since this block is in motion, it exhibits what is called kinetic friction. So the frictional force in this case is simply what? The kinetic friction, which is Fk, which is the friction applied to an object when the object is in motion. Now, I also said in my videos on friction that whenever two surfaces come in contact, there's always going to be a normal reaction force which acts at 90 degrees to the surface in contact. Now, the surface of the 14 kg block is in contact with the surface of the inclined plane. So, which means there is going to be a normal reaction force which acts at 90 degrees to that surface. And this normal reaction force is taken simply as N. I also said that every object that has a mass automatically has a weight which acts vertically downwards. So since this object has a mass of 14 kg, then the weight of this object is simply going to be what? Mass times gravity, which is 14 times gravity is 9.81. So the weight of this object is approximately going to be, let's obtain 14 times 9.81. That simply gives us 137.34 newtons. So this becomes the weight of this object, and this weight acts vertically downward. So I have a weight which is acting vertically downward, and the value of that weight is 137.34 newtons. Okay, I also said in my video on statics and kinetic friction on an inclined plane that the angle between any vertical line and any inclined line is taken simply as the angle of inclination. So I have the weight, the angle between the weight and the normal reaction. Also keep that in mind. Always in inclined plane friction, the angle between the weight and the normal reaction is always taken as the angle of inclination, simply because the weight is a vertical line and the normal reaction is an inclined line. And I said the angle between a vertical line and an inclined line on an inclined plane friction is always taken as the angle of inclination. So this angle is simply 30 degrees, and you have this. Now, having obtained this force system, you observe that my normal reaction is inclined. The force which is causing motion is also inclined horizontally up, whereas our kinetic frictional force is also inclined horizontally down. The only odd looking force in this system is what? The weight of the object. So let's draw a free body diagram over there to explain this concept properly. All right, so we have the weight of the object here, we have the normal reaction force inclined as can be seen here, and the angle between the two we said is 30 degrees. The weight itself is 137.3 newtons, and our normal reaction remains N. Now, if you draw an imaginary line, let's say we draw an imaginary line here, okay? If we draw an imaginary line, something like this, you observe that the weight is purely vertical, but the normal reaction is inclined at an angle, okay? But if you take a look at the whole system, P is inclined, F is inclined, and the normal reaction is inclined. Only the weight is looking odd. So it will be wise to resolve only the weight to be what? Vertically inclined and horizontally inclined. That's a wise thing to do. So whenever you're solving inclined plane problems, always keep it in mind. Do not resolve the force or the frictional force itself or the normal reaction. Rather, resolve only the weight, since only the weight is the odd force here, okay, in terms of position. So we simply resolve the weight to be vertically inclined and horizontally inclined. As such, this remains our vertical inclined line. So this is our positive y if it is pointing upwards, just like normal reaction is pointing upwards. And this remains horizontally inclined, okay. So if it is pointing up the plane, according to that motion, it is positive. So this is positive x in the inclined direction. So the weight needs to be resolved. Now, if here is 30 degrees, that means, remember, this and this makes an angle of 90 degrees. I said earlier that the normal reaction and the frictional force in my previous videos, I said the normal reaction and the frictional force makes an angle of 90 degrees to one another. So you can see the direction of the frictional force. It can also be likened to be this direction. So this is normal reaction, this is the frictional force. So we make an angle of 90 degrees to one another. All right, so if here is 30 degrees, automatically here becomes what? 90 minus 30, which makes this angle here to be 60 degrees. Now, we need to now resolve the weight to be vertically inclined, resolve the weight to be horizontally inclined. And I said that in order to resolve the weight to be vertically inclined and horizontally inclined, you simply hold the tip of the arrow of the weight, pull it to meet the particular direction you want to resolve in that quadrant where the weight is found. Now, if the weight passes through an angle to get to that direction, multiply the weight by cosine of the force it passes through. So that means that if I want to resolve this force to the vertical incline, I will hold the tip of the arrow of the weight, pull it to meet this line. Observe that this weight moves all the way from here down to this point, covering this angle 30 degrees. Since it passes through 30, what do? Multiply this weight by what? Cosine of that angle. So over here, I have my weight component, and the value is what? 137.34, okay, 0.34 newtons, please. 0.34 multiplied by cos 30. This becomes the component of my weight in the y direction. Okay, so if you do this, you're going to have the value. So let's simply call this wy. That's the weight in the y direction. So let's find 137.34 cos 30. So that gives us 118.9 newtons. So the component of this weight in the y direction inclined is taken simply as 118.9 newton. Similarly, you resolve this same weight to the horizontal incline. Still the same theory. Hold the tip of the arrow, pull it till it meets the horizontal line. Now you observe that if you pull this force from here till it meets the horizontal line, this force moves all the way from here down to here, covering this angle 60 degrees. And you observe the arrow direction, this force will point downwards here. This force points downwards when it gets to the horizontal component. And the value becomes what? This force multiplied by cosine of the angle it passes through. So I have 137.34 multiply cos 60, because the angle it passes through in this case is cos 60. So that means W of x, which means the weight in the x component inclined, is now going to be, let's obtain 137.34 multiplies cos 60. That simply gives us 68.67 newtons. Okay, now the other way you can solve this is, if you don't want to carve out this angle here as 60 degrees, you can simply say, since this force did not pass through 30 degrees to get to this quadrant, all you need to do is multiply this force by what? Sine of 30 degrees, and you still obtain the same result. So if the force doesn't pass through an angle to get to the component you're resolving to, what you simply do is multiply the force by the sine of the angle it didn't pass through. It gives you the same result. So for instance, if you look for 137.34 multiplied by sine 30, since on getting to the x component, it didn't pass through 30 degrees, you're still going to obtain what? you're still going to obtain this same result. If you multiply this force, 137.34 multiply sine 30, you're going to obtain the same result. So that's like a shortcut approach to resolving components in either x or y direction. Okay, having done this now, we have now been able to resolve the weight to be inclined and to be inclined vertically and horizontally. So it makes the work easier now. I have everything now purely inclined on the system. So you employ your equilibrium equation. The first equilibrium equation is summation of horizontal force is equal to 0. But now, forces are positive in the direction of motion. Since in the first case, the P or the force is pulling this object to move up the plane, which means motion up the plane, horizontally up the plane is taken as what? Positive. Therefore, motion horizontally down the plane will be taken as what? Negative. Now, the idea is to always make friction a negative force because friction is always a negative force. A force that acts to oppose motion is always considered a negative force. So let's find this summation and see. You look at the first system, I have my force P pulling this object in the right or up the plane. And since motion is up the plane, it means P remains positive. So you simply have P, which is positive. Similarly, I have the kinetic frictional force opposing that motion, causing this object to come to rest, resisting the motion of the object. Since it is resisting the motion of the object, it becomes what? Negative. So I simply have minus Fk because direction is against the direction of motion. But not forgetting, we have resolved this weight. We have resolved this weight in the plane of motion, that is to the x direction. Remember summation f of x, and this is w of x, which is a component of the weight in the horizontal direction inclined. Observe that this arrow is pointing down the plane when we resolve this weight. So which means the weight is in the same direction as the frictional force acting down the plane, opposing the motion of this object. As such, this weight component becomes what? Negative because it is opposing the motion of what? The weight or the object. So it becomes minus 68.67. So these are all the forces acting in the horizontal direction. Therefore, the whole of this is equal to 0. So we make P subject. We are told in the question to find the value of P, which cause motion to impinge up the plane or down the plane. So we are looking for the value of P. Let's simply make P subject. P is now equal to, I will simply send minus Fk and minus 68.67 over to the other side of the equation. If negative signs cross an equal to sign, they become positive. So you simply have Fk on the other side, okay, plus 68.67. You can call this equation 1. So our next target now is to find the value of what? The kinetic friction, Fk. Not forgetting that kinetic friction, Fk, like I told earlier, is given simply as mu k multiplied by what? The normal reaction, where mu k is the coefficient of kinetic friction, and in the question we are given the coefficient of kinetic friction as 0.4. Okay, so which means all we need to do is to find our normal reaction n. And how do you find your normal reaction? I explained that in the previous video. Please do well to look at the description of this video to get the link of the previous video on static friction and kinetic friction on an inclined plane for proper understanding. Okay, so I explained that in order to find the normal reaction, all you need to do is simply what? Consider the second equilibrium law, which is summation of vertical force is equal to 0. So the second equilibrium law, summation f of y is equal to 0. And since motion is not vertical in the plane, motion is horizontally inclined or off the plane and not vertical. Therefore, you simply consider vertically upward forces to be positive and vertically downward forces to be negative on the incline. So in this case now, inclined vertical upward force are taken to be what? Positive, whereas inclined vertical downward force are taken to be negative. So that simply means my normal reaction, since it is pointing upwards, it is taken simply as what? Positive. So you put it out, n is pointing upwards, taken as positive. Again, let's look at the first system. I have n pointing upwards, positive. Now I have the vertical component of this weight resolved earlier, pointing downwards, as can be seen here. Okay, the vertical component of this weight wy is pointing downwards. Since it's pointing downwards, it is considered as what? Negative, and the value is 118.9 newtons. So you have minus 118.9, and this is equal to 0. Now, that means we can simply find our normal reaction by simply sending minus 118.9 over the other side of the equation. This simply implies that my normal reaction N is going to now be equal to negative sign cross and equal to sign becomes positive. So I simply have 118.9 Newton. So this is now my normal reaction force. Now, if I know the normal reaction force, it means I can find the kinetic frictional force since I know the coefficient of kinetic friction. So if you plug that here, then you're simply going to have where Fk is equal to mu k was given in the question as 0.4. So it becomes 0.4 multiplies 118.9. So I have 0.4 times 118.9. So let's obtain this value and see. That gives us 47.56 newtons. So if we have the kinetic frictional force to be that, then you plug it into equation 1 and that gives you the value of the force which causes motion of the plane. Therefore, P is now equal to Fk plus 68.67 and Fk has a value of 47.56. So we have 47.56 plus 68.67, 68.67. Therefore, let's add these two up and see. That gives us 116.23 Newton. So the value of the force P which causes motion of the plane is simply taken as 116.23 newtons. All right, so this is the value of the force which causes motion of the plane. And of course, if you compare this value to the kinetic frictional force, the value of the kinetic frictional force is 47.56. Since it is less than the force which causes motion of the plane, it means that motion will continuously go up the plane because the value of the applied force is greater than the kinetic friction. All right, so the second part of the question says, what is the value of P which causes impending motion down the plane? So that is simply now saying if we reverse the whole situation and we simply call here P. P is pulling this object down the plane. Of course, if the object is moving down the plane, then it means that I'm going to be having frictional force to oppose that object up the plane. Okay, and since this object is in motion, it means this frictional force always remains what? Kinetic frictional force. So we are simply now taking a reversal of everything we've done. Everything we've done here remains the same, but now we are considering a reversed angle when taking our what? Equilibrium equation. Okay. So I want you to keep in mind the normal reaction still remains the same. So summation f of y holds truly in this same situation. Of course, motion is not vertical, so the normal reaction and the weight over here, the normal reaction value remains 118.9 newtons. It remains the same. So the only place that is being affected now is the direction of motion. Since motion is horizontal, in this case, the motion is acting down the plane. So this simply means if we are considering our horizontal force component or summation of force horizontally, then motion down the plane becomes positive because force should be positive in the direction of motion. So if motion is down the plane, then every force that acts down the plane in this case becomes positive. The idea once more is to make always frictional force a negative force. Okay, so let's effect that now in the horizontal components. All right, so welcome back. Now, if the normal reaction force still remains 118.9 newtons, then that simply means that the kinetic frictional force still remains 47.56 because it is always mu k multiplied by n. And mu k, which is the coefficient of kinetic friction, was given as 0.4. Once you multiply that by 118.9, you still have that same result. So the kinetic friction does not change. The value remains the same. Now, let's apply our new law now. Summation f of x is equal to 0. Now, motion inclined down the plane is positive, whereas motion inclined up the plane horizontally is negative. That's the whole idea. Every other thing remains the same. So let's check. P is the force now reversed. The force is compelling this object to move down the plane. So since motion is down the plane, force is positive. I have P. But observe that the frictional force is opposing that motion, trying to compel this object to remain at rest by opposing this motion. As such, the frictional force becomes negative since it's acting up the plane. It is acting against direction of motion. So we have minus Fk. But now observe that the weight, when we resolve this weight horizontally, it was pointing down the plane. And since motion in this case is down the plane and weight horizontally is down the plane, it means that the weight is moving in a direction of motion. That makes the value of that weight to be what? Positive. So therefore, the value is 68.67 and it is positive. So we have plus 68.67. So these are the components of all the forces in the horizontal direction, and the whole of this is equal to 0. So you observe that in the first case, when motion was up the plane, this weight was negative because the weight was acting down the plane against the motion. But in this case now, the motion of the object is acting down the plane. Therefore, the weight component horizontally becomes what? Positive, because it is acting in the direction of motion. Again, which tells you that the forces are always positive in the direction of motion. So the idea is always to make frictional force to be what? Negative, because frictional force must act to oppose that motion. And any force that acts to oppose motion is considered a negative force. Okay, having known the value of Fk, we can simply send everything over here though. So we have that our P is equal to negative sign, cross and equal sign becomes positive. So I have plus Fk, now plus 68.67 crossed over becomes negative. That is minus 68.67. So let's plug in this value and see what we are going to obtain. Fk, we obtain Fk already here as 47.56. So I have 47.56 minus 68.67. 68.67. So this implies that our value P is now going to be equal to, let's see what we obtain, 47.56 minus 68.67. Now, this gives us negative 21.11 newtons. Now, you observe something here, that this force is a negative force. The reason now is to tell you that the force is less than the kinetic friction. So, which means in this situation, the object will remain where? At rest. If the applied force is less than the frictional force, then the object remains at rest. That simply tells you that this is no longer a kinetic friction, but rather what? A static friction, because that frictional force is greater than the applied force. Therefore, the object will remain at rest, exhibiting what is called static friction. So this simply implies that in this situation, when it is reversed, the frictional force is no longer a kinetic frictional force, rather it is what? A static frictional force, because its value is greater than the applied force. As such, the object will remain at still. That is why you're having a negative sign. So the negative sign only tells you that the applied force is less than the frictional force, which simply implies that the object will remain in static position or at rest. All right, guys, so that's it on that video on static and kinetic friction on an inclined plane. I hope you find this video very interesting and helpful. Please, if you do, I would like you to encourage my work by liking my videos, commenting nicely, sharing to your friends, and of course, if you're new to the channel, do well to subscribe and turn on the notification bell to keep getting updates when new videos drop. In the next video, I am going to show you how the angle of inclination is equal to the angle between the vertical line and the normal reaction. All right, so ensure not to miss out on that video. Thanks.